Today I want to talk about converting the compound, or not the compound, but the condensed structure as it's called. I mean, the same thing, right? Into the actual Lewis structures themselves, okay? And then the next video, I'm going to talk about all three of them. So I'm talking about Lewis structures, condensed structure, and then ultimately go into the bond line structures in the video. So the link for that will be in this description. So make sure you check it out. So now I'm given this condensed formula, and I'm saying, okay, well, what is the Lewis structure? Well, I've made a video on the functional groups and their kind of their moniker. You usually see some sort of way they're written, and that will tell me the functional group. So the first thing when I'm looking at these problems is that I want to identify my functional group and I want to see if there are any branches. What do I mean? Okay, well, I see that the COOH. Whoa, man, that's crazy. That reminds me of a carboxylic acid. And so I know I have a carboxylic acid, and we know how to draw carboxylic acid. Well, do I have any branches? Okay, well, no, I don't have any branches. There are no branches, okay? So I see a COOH, and I see carboxylic acid. Now I see a O that's sandwiched between two carbons, okay? Now, do not assume that this is an ether, right? An O that's sandwiched between two carbons. You don't want to assume that. You want to assume that the functional groups at the ends are what you assume, but this could actually be something different, okay? And we're gonna see. Okay, so how I want to approach these problems? Well, it's like reading a book. So I'm going to start from right to left. So I have a carbon that has 3 hydrogens around it. Okay, well, my carbon only need one more bond to form the octet, so therefore it has to be bonded to this carbon, which is right here. Okay, well, I see that I have an oxygen that's sandwiched in between, and I have a CH2. Okay, so if I'm looking at this, I have an oxygen that's sandwiched in between. We know that's an ether. Okay, and then this oxygen is bonded to a carbon that has 2 hydrogens. Okay, so I'm right here now, and then this carbon is bonded to a CH. Okay, so this carbon is bonded to a CH, so there's my CH, and so there's my CH right here, and it's bonded, this carbon is also bonded to a CH. Okay, well, look, this carbon has 4 bonds, this is missing 1. Okay, well, the only way for this condensed formula to be correct is if we have this double bond here. And now you can see that our carbon has 4 bonds. It's a CH as predicted. Okay, so our carbon is so that's something that you could see. We want to fulfill. We just want all we're doing is fulfilling the octet rule with most of these problems you'll see. Okay, so now we have our 2 CHs. Okay, well, that's nice to know. And then we have this that's bonded to a carbon. And when we say this is a carboxylic acid, and we know how to draw carboxylic acids. Okay. So this would be the Lewis structure for this condensed molecule here. So let's take a look at another example. Okay, so I have this here. COCH2 CHO. Okay, so I want to convert this to the Lewis structure, the corresponding Lewis structure. Well, again, it's like reading a book. So I'm going to start from the nitrogen. I have a nitrogen, and we know this is bonded to a carbon. Okay, now notice that this carbon is just a carbon. Okay, so we know this carbon is bonded to a CH2. Okay, so that's nice to know. We have a CH2. Okay, we have a CH2, but notice my carbon here is missing what, 2 bonds? It needs to satisfy the octet rule. So the only way for this to satisfy the octet rule is if we add those two bonds in there. Okay, and this will also make nitrogen happy. Okay, so again, now we have our CH2. Everything is okay on that side, and now we have the CH2 that's bonded to a carbon. Okay, that's bonded to a carbon. Okay, that's bonded, yeah, so it's bonded to a carbon. Okay, well, notice that this is now not an ether. Okay, this is not an ether. And the reason why it's not an ether is because if I put an O here, okay, this carbon has no way of satisfying the octet rule because I can't put a double bond here. All right, so I can't put a double bond here. So therefore, this has to be what we call a carbonyl, okay? And it's a carbon that's double bonded to an oxygen. And notice that this carbon now satisfy the octet rule, okay? So this CO represents this. So do not assume that an oxygen that's double bond, that's sandwiched between two carbons, that automatically is an ether. That's incorrect. You got to be very careful, okay? So now that we have this carbon that's bonded to an oxygen, well, this carbon is also bonded to a carbon that has two hydrogens, okay? And remember we said that this functional group is an aldehyde, and we know how to draw aldehydes, okay? Now there's something I want to point out with this one, okay? Anytime you see a CN in the condensed structure formula, think about triple bonds, think about the nitrile functional group. So let's just call it nitrile, okay? And this is an aldehyde. So we have an aldehyde and we have the nitrile, okay? So let's look at another example. Let's look at this one. CH2, CH, CH, OH, CH2, CO2H. Okay. So what would be the lowest structure for this? Well, again, the first thing I want to do is identify my functional groups. It makes the problem much more easier. So this CO2H, we know this is a carboxylic acid. Okay, we know this is carboxylic acid. We know this is an alcohol, okay? This is OH, alcohol. But look, it's in a bracket. So what does that tell us? This is actually a branch, okay? So this is branched off the longest continuous carbon chain. Okay, so let's draw a little structure. So we have a carbon that's bonded to two hydrogens, okay, and it's bonded to a carbon that have one hydrogen. Well, again, the only way for this carbon to satisfy the octet rule is if I have my double bond. I put a double bond in between it, and you could see that all we're doing is just making sense. All we're doing is fulfilling the octet rule. Okay, that's all we're doing. So if I see that this carbon, like we just did, was missing a bond, the only way for it the molecular formula to match up with the lowest structure is if this had a double bond. Okay, so now we have a carbon that has a CH. Okay, well, this is this CH, and this is bonded to a CH. Okay, so this is bonded to a CH. Okay, so we have a CH, and remember, alcohol is branched off, so or OH is branched off there, okay, and then we have this carbon that's bonded to the C that has two hydrogens around it, okay, and then we have the CO2H, which again is a carboxylic acid functional group, so we know how to draw that. Okay, C double bonded to an O, that also has an alcohol, that's a carboxylic acid functional group. Let's look at another example. What about this one? CH2, CH, CH3, CH, C, O, CH3, COO, CH, COO, CH3. Okay. How about this one? How are we going to write the lowest structure for this? Well, again, it's like reading a book. We're going to start from left to right. So we have a C carbon that's bonded to two hydrogens, that's this, okay, and it's bonded to a carbon that have one hydrogen on it. Okay, now again, the only way for this carbon to satisfy the octet rule is if I tack in my double bond. Okay, and by the way, this functional group is called an alkene. Okay, forgot to mention that. So this is an alkene. Anytime you have a carbon-carbon double bond, that's actually a functional group, so that's called an alkene. Okay, so we have the carbon that's double bonded to the CH. Okay, the only way for us the way we got double bond was we said, okay, well, this is missing a bond, so we had to form the double bond. Okay, and then we can see that this CH is bonded to a carbon. Okay, so that's nice to know. So it's bonded to a carbon. Now we have a CH3 that's branched off. Okay, we have a CH3 that's branched off this carbon, so we have our CH3. and maybe I should have wrote it as 3 hydrogens spread out, but it doesn't matter. We're talking about Lewis structure here. So we have a CH3. Okay. Yeah, so yeah, this is not Lewis structure. Let's draw the hydrogens explicit. So CH3. Okay, we have our CH3. No, that's a Lewis structure. And then this is bonded to a carbon that has a hydrogen. Okay. Well, the only way for this carbon to satisfy the octet rule, again, is if we form the double bond. Okay. Now we have a carbon that's bonded to the hydrogen, and this is bonded to a carbon. Okay. This is bonded to a carbon. Okay. Okay, so this is double bond. So we took care of that. Now we're at this carbon. Okay, so this carbon is bond. This carbon is here. Now we have COOCH3. Well, if you did not know, this is a this whole thing here is what we call an ester functional group. Okay. Okay, so this is what we call an ester functional group, and so this carbon is bonded to a carbon that's double bonded to the oxygen. Okay, and we have an oxygen that's sandwiched, and we get our CH3. Okay, so here's another cue. COOCH3. This is called an ester. Okay, and esters are different from ethers. Ethers just if we're ignoring the carbonyl here, and let's say we have just the carbon like this. This COC would be an ether, oxygen double bonded between carbons, but because we have this carbonyl group here that's adjacent to the oxygen, this is what we call an ester. Okay, and so you could see the pattern. So the pattern with these, you want to look if you have any branches, look at your functional groups. It's very important to know how to write the functional groups, how the functional groups are written. And in fact, I want to talk a little bit more about, some of the common functional groups. So we know carboxylic acid, you'll usually see that COOH or CO2H. You'll see aldehydes. Okay, so these are carboxylic acid. Yeah, carboxylic acids. Okay, you see aldehydes as CHO. Okay, we just talk about esters, so you'll see esters as COOCH3. And to be honest with you, this is not only okay. This carbon chain could be extended. So in this case, we only had a CH3 at the end, but in fact, we could have had a CH2 and a CH3, but it still would be an ester. This the fact that you see COOC, that's an ester. Okay. Okay, so those are the more common functional groups you'll see. Again, alcohols, you'll see OH, but again, these are usually branched off.